Welcome back to class, dear students. In this lesson, as we continue on JavaScript, AI Enhanced Web3 Front-End Development course, the JavaScript section, we are talking about JavaScript, asynchronous programming, and promises. So, we will explore the fascinating world of asynchronous programming. What does it mean? When you talk about asynchronous programming basic, asynchronous programming allows JavaScript to perform long network requests or time-consuming tasks without blocking the main thread, keeping your Web3 application responsive. For example, the set timeout function is a basic example where a callback function is executed after a set delay without halting the execution of subsequent code. So then, when you hear synchronous, I need to first give you difference. There's what we call synchronous and asynchronous. So synchronous programming execute tasks one after the other, like we have learned in the previous lesson. You can see that asynchronous is like top down. That means when you say synchronous, it means things sync one after the other. This is done. So, and since JavaScript run compiler and engine read from top to down, just like we human being normally read. You don't want to read now. If this happen to be like a kind of a book for you to read, you don't start reading from the bottom up and then you say it will make sense. No. So, or you start reading from the last line. If this is about a paragraph has about 3-4 lines of text, then you start from the last line to read it to the beginning. It will make no sense. So that is why the code also read it like this. So doing that is synchronous, and that introduced a lot of limitation for JavaScript and a lot of other programming language like that. So one of it is what we learned that brought about the previous one we did about lesson we have discussed about. Yeah, I think where we talk about, let me point that. Yeah, about flow in JavaScript, about conditions and loop, using if statement and other things like that, so that we can interrupt those synchronous flow with some conditions, so that we can say, okay, don't execute this code even though it comes first if a particular condition is not met, so you can skip it to the next one. But beyond that, what about if you are trying as a dApp? You always have to do with API. That's why we'll still learn about API after this JavaScript section, so you can see it here, a full detailed crash course for you. Now, when you are dealing with things like API, it's like you want to interact with your smart contract, which is not on your front end of your dApp. You will need an API to communicate. In such a case, you and I know anything that has to do with communication from one computer to the other or one server to the other, at times there could be delay. At times you cannot always predict what the other server will do or how it will respond. Maybe you can always predict you will make a call, but you can't always predict if the call will instantly go through, or you will get a response that say, okay, wait, or a response that will even just put on hold until 5, 10, 20 minutes or whatever, or some seconds, or a response that will totally tell you this thing is down, it's not available. So when you are dealing with such, and you are dealing with a code that just can't stop, just running from top to bottom in a matter of seconds, you understand what I'm saying? You will see that means a lot of your API call and all those things will not be done successfully before the next things will be activated. So if user is to mint, let's say, which will be part of things will still, courses I will still create later in future, I believe, will be, we are talking about fungible token, minting them now. What about if I want users to mint NFT? And then once they mint this NFT, they will now be able to use it to unlock the content on the page. But if they connect their wallet, they have the NFT good. it will unlock. But if they don't have it, they will need to mint first, which means I will need to communicate with the smart contract, get them mint, either it's free or paid, then confirm that they now have it, which will take some time to mint, to have it in their wallet, and then confirm. If my code is just performing synchronously and can't wait, there's chances that even from the point of like trying to do the mint the NFT, it will just cut the app off and like error or something, because it won't have the NFT. Whereas if we are able to make sure in a way that there could be waiting time, like okay, maybe other code could run, but this particular code block had to wait to get response from any call or whatever we make before it can be executed. That's one. And two, even if it's not completely executed, then that code, this particular code, should never be closed like a fully executed code. No, because there are some part of it that may rely on the feedback from that API result. So that's why asynchronous is so important. So I hope I've been able to give it a basic reason why it's so important and why it's being used. So you see, end tasks must complete before the next begin, leading to potential blockages. That's the problem, like I told you, that first must end, then move to next. So if the first one take longer than some time to end, it just got cut off because the next one must be. But when you talk about asynchronous programming, then you allow tasks to be executed separately from the main program flow, letting the application continue running while waiting for the asynchronous tasks to complete. So it's two things. The code is aware. It's not just skipping that code entirely and then go and do others and that's all. No, it's aware this asynchronous code is there, one. Two, it refuses to close that complete code execution, opens up the gap, whatever function or things that is interacting with the feedback from that asynchronous function is always open, always ready, always waiting for the response from the asynchronous. So with that, nothing is blocked off. Not that by the time that respond, then the app has already closed down. Then the response is not even coming through to the app. So you can imagine now the user is maintaining, maybe there are congestion in the network. Then it's telling them this token is minting. Then after maybe few seconds or a minute, something has closed. Then it's minted successfully. The user will not know, and things can just give bad experience to user. But then it keep listening, and once that happens, you can build something like those alert or things that just say minting, and then once it gets that feedback through the asynchronous programming, it feeds it back and says success. Then user knows what is on, and no matter like a minute or two, the user will still be patient waiting because they are seeing it that okay, this thing is working on. So that's why asynchronous was introduced. Callbacks and callback are function passed as argument to other function executed after the completion of an asynchronous operation. However, excessive use of nested callback, known as callback L, can lead to complex, hard to maintain code. Promises offer a more elegant solution to this problem. So that's what we are saying, like callback are like, what should we do when all these things are done, or like a backup function. That's how a callback function used to be. But when you nest them, they can cause a lot of compromise. In fact, it's one of the issues that hackers and things like that use to compromise some smart contracts. So all these are what asynchronous and promises. So promises is when asynchronous is now working, it holds something called promise, because it's talking to another server or another computer or whatever, or this blockchain, and it's like sending something. And once it sends it, it's expecting, like it's a promise. I'm expecting it to be delivered, because once I've sent, the promise has been created that something must be delivered, even if it is failed, even if it is the server is not responding, even if it is what you are looking for, it doesn't even exist here. I am expecting, the promise has been created that is expected to be returned back and be fulfilled by returning it back through the response or something. So it can be one of the three states: promise as an object representing an eventual completion or failure of an asynchronous operation, can be pending, fulfilled, or rejected. So those are the three states it can be, which for like blockchain can be like maybe like processing, then success, executed on the blockchain, added to the block, or failed, transaction rejected, maybe due to some things and things like that. So you create promise using the promise constructor, which takes an executor function with resolve and reject parameter. So here it is now. You see const fetch data, then fetch. This is an API. You are calling an API. Don't worry, we'll still do this, so you don't need to remember that. Then you see it's like when you receive the promise you are receiving from these people, then take that response and make sure it's converted into JSON. We also learn about what a JSON is, so don't be confused. When you have it in JSON, then try to go through the data, and this one says console log the data. If not, if there is error, if you are not able to get any meaningful data, then ensure you also catch the error, so that the asynchronous something doesn't get just opened infinitely, or the user gets no feedback. Imagine you try to come and mint on this site now. You click mint, it said reach, but you are not even getting minted, how much you have minted, everything. That would be a very bad user experience. So that's why there will always be need to catch the error. Then you see it now, error fetching data. So it's either you get it like this is pending, then you get a response. Then when there is a response, try to put it in JSON. But if there is no response, if it is error or something, you catch it as error and then you console log it. From here now you can take this data and use whatever you need from it. That's what you will learn in the API. So asynchronous / await for cleaner asynchronous code. The asynchronous await introduced in ES 2017 provide a more concise and readable way to handle asynchronous operation. So we can see when we look at our code that we had before, after we have this code now, and this is what we did: simulate asynchronous operation. The simulate token mint function simulates an asynchronous token minting operation using set timeout and return a promise. It will solve the number of successful minted token or reject with an error message if minting limit is reached. So you can see what we have done before. We want to try to turn some part of it to be like asynchronous function, so that you can reject some things, you can return new promises, you can reject some things, you can make use of some things. Promise consumption, the then and catch method are used to handle the resolved or rejected state of promise, updating the mint status in the DOM accordingly. Set timeout function, the timeout function is used to introduce a delay, mimicking the behavior of asynchronous operation like network request. So this one is trying to mimic an asynchronous. We are not really making API, so we are not actually using the full asynchronous, but by using things like time to delay it, then it's just as if we are doing. So this thing will keep opened until that time is reached. But if we are using the full asynchronous, making API call, which you still see them later, you might not really need to set time, because if you set time and nothing happened before that time, it can cut off. Why after it, if any feedback is gotten, your application, your dApp has closed and there is no feedback for the user, which is a bad user experience. So now let's copy this. and have it here. So I always have that full sum, so you can replace and see what I've done. Then you can refresh this, and we have everything working back. Invalid wallet, mint. You see, so minted 1 token. So all this feedback, all these things matters a lot. And you know, this was so fast because we are just simulating a token mint. You get what I'm saying? We are only simulating. We didn't actually perform it. And that's why you remember function, make sure you give the name. From this simulating token mint, I already give you an idea that we are not actually minting, but we are simulating. Because if you actually want to mint, I need to connect and do an actual like other things like Web3 JS and things to connect and do like API call. This now, and always as usual, you have the HTML in case anything is not working, make sure you recopy it. That's why I always try to make sure in case anything doesn't work, you mean maybe anything has changed, copy it as well. Then you run and see whatever you got here. Yeah, so we have it as usual. Then you can mint into it 10,000 straight. See, successfully minted, and then I can mint again. You see that it took a while before the response comes. It's like it's trying, it delays it based on what we put here, which was this. That I should delay it for a certain seconds, like I think this is like a milliseconds or so. So it delays it. If we increase this now to like 20,000, for example, let's see what will happen here. Ready to mint, invalid, Q, then 1. You see that it took time, a lot of time before this, and you see that this is not updated yet. So imagine this like you are trying to communicate with blockchain. Let's say, for example, now you see successfully minted 1 token. It's like, let's say Ethereum now, which is take a lot more time and things like that. So those, you could take like 15, 20, 30 minutes to have minted that at a costly fee. Maybe in years you'll be watching this, that might have improved. So you understand what I'm saying? So you can, if I return this now, it becomes much faster again, and you can see. So that's how Asynchronous also work, which we will see fully in the when we are doing the API call, because that's the best time to use Asynchronous, when it's communicating, especially outside of your code or your dApp, like the smart contract and things like that. So that's it here. And so that's it. In case you have questions, please use the comments. See if students already have questions you ask before. Take time to read this. It helps you to learn more, because you will see what your fellow students before you add experience as challenges, which you might not even notice, but it will help you as you develop as well. So, and if it's same question, you might just reply, oh, this also helped me. That's different, but don't repeat the same question that we've already answered. Might not be responded to. That's it. Join the Discord, DPE official Discord, for partnership with other Web3, support within the community and all those things. But for specific course lesson support, your best bet is to act here. That's it. And also the resources are helpful for you to consult to learn more. I remain Solomon Foske, the Programming University. Please keep the programming spirit alive. Your only assurance to succeed in the long term as a developer, because if you give up, there's no chance for success. But if you keep pulling, keep grinding in as a developer, especially with this AI age, you get better at the end of the day. Now, please always do good to humanity and nature. With your programming and any other knowledge you have are not evil, to make the world and universe a better place for us. See you in the next lesson. Peace and bye.